All right, welcome back, everyone. Today is kind of a continuation of program exploitation, just to get it on the recording and to make sure we cover all the content. Because I did get sidetracked a little last time, and I want to make sure I walk through all of the things I want to cover. So, in the meantime, let's do a quick review of what's going on. Okay. Um, these are some of the tools that I've been using to demonstrate the program exploitation. GDB, pretty good, but Pwn debugger, even better. File checkstack, you use them to see if you have any protections that prevent you from doing some of the easier exploits. And of course, Pwn tools is a really good um, it's a really good framework for developing exploits that don't involve you having to painfully type every character and look up how to type 0 hex 12 into a terminal, which is not a character on your keyboard. Buffer overflow. I'm going to go right back into the echo the stack challenge just to make sure that it gets done properly. Okay. Pull up the folder and okay. This is not the right folder. Give me a second. CTF, my CF, go. Okay, there we go. Let's open it right here. Go back over. Okay. If you remember the challenge of echo escape, what essentially happened was, ignore this message. Essentially happens is we need to figure out a way to trigger the win function, but the win function never gets called in main. So we have to mess around with the stack to make sure the return address on the stack gets overwritten to whatever address belongs to the win function. Actually, let me zoom in. Can everyone see the code okay? Big enough? See? All right. So first things first, how do we figure out the location of the win? Well, let me just open up our good friend Pwn debugger and cd go escape one Pwn debug boom. Okay, loading it in. And what is the address? I just do info address win, and it is at this address 0 hex 401256. Okay, so essentially if I am able to get the buffer overflow, I just have to overflow it and then somehow insert this address into the memory location of the stack return pointer. Okay, then let's just try doing it. Let's see, function, even though there is no I'm running the executable without the -g flag, so I can't exactly see the original source code. So I can't be like break at line 30. So right before whatever function ends it, I can always in GDB and in Pwn debugger, you can always run the command start, which just puts you at the beginning of the function at what essentially is the first line of code. Of course, it sends you to whatever first assembly instruction is in the code, but yeah. Then, let's see. Just for visibility, I'll just run the debug, the one with the -g flags, just to make it easier to see what's going on. So exit on debug, debug. Okay, and start. All right. Then source code, I will set a breakpoint for line 30. So after it does the reading of the input buffer, and just run it. And if you remember, I needed to put in a bunch of characters to figure out what is the exact offset from my buffer that I'm putting into to the return address. So I'm just going to use the cyclic pattern. So it's just a random number, really long string of numbers and characters, but it has a specific pattern, so you can tell that, oh, if the thing I want to overflow begins with this character, I know that it is precisely this number of characters off. So buffer overflow cyclic pattern generator. Let's say 50 should be enough. And if you remember that the return address is always located one address on the stack above the base pointer, the RBP address for your function. So as you see, normally this, when you exit a function, it's going to go to libc function start column main. That's essentially what's run every time you run a program in the terminal. But I want to control it so it goes to win instead. So I see that might not have enough to overwrite. So you know what? Let's not do 50. Let's do 70 just to be sure. I'll just run it again. Okay, I've definitely overwritten something at this point. And I can see that this is the backtrace. It's pulling the data from the stack. So I can see that, oh, initially I'm currently here, and the return address is, well, normally it was something, but now it's some random garbage data. So I'm gonna just copy this data into the offsets, calculate, and it can tell me that the location of the return address is precisely 56 bytes away from the buffer itself. So I know that when I develop a payload, I need to first insert something to fill in those 56 bytes, and then the actual address I want to type in. So just give me a pattern of 56. Okay. And then afterwards, I want to type the address. Let's see, info address win. This has been compiled with protection, so give me a second to see. GCC vuln.c. I think it's no pi, no canary. Let's see. GCC no canary, no pi. No pi. FN no stack protector. Dash dash. F no stack protector. This. Okay, then I'll just run on debug on a.out. Just run it again. So address win. At file compiled without debugging. Give me a second. I just want to make sure that whatever code I'm cooking up to do demonstrations is the exact same, has the exact same state as the original binary. So our useful tool checksec file equals vuln. That's vuln's original. No canary, no pi. Okay, no canary, no pi. Then no pi, no stack protector, which is the canary. Okay. Pro data. Ignore warnings. Ignore warnings. That'd be C. Suppress all warnings. Error data cannot be used when making a compile. Recompile with fpi. There we go. Fpi. Go. 1 dash. Okay. And run on debugger on a.out. then function info address win. There's a little difference, but we can overcome it. I believe in the original one, the address is at 0 hex 401269, but this is at 1269. But we can pretty much demonstrate the exact same thing. So just give me a compile it with -g and debug a.out break 30 run. Okay. Just make sure we can verify it with let's say 60 again. Make sure that we overflow the return address once again. Looks like random garbage did get put into here. So what is the offset here? Looks like there is, with some of the protections removed, the offset is actually 40, not 56. So hit that. Run. And then once I have the offset, insert the payload. And recall that a lot of all the programs we're running is going to be in little endian. So if I just type 0 hex 1269 into the program, it's actually going to be read backwards. The computer is going to think, oh, I actually want to read address 6912. So have to type it in backwards. In this case, I will generate it with CyberChef and turn to payload. How do I type it? Because see, I can't just type 0 hex 121269. The program's going to read it and think, oh, I'm typing the literal characters. No, I want the characters that represent the literal hexadecimal values 1, 2, 12, 0 hex 12, 0 hex 69. So 12, 0 hex 69 from hex that produces this DC12 and the, make sure I just get it. I'll just try it and see if it works. So after this, I'm gonna need I, and then I'm gonna need DC2. How to type DC2 in terminal? You can actually do it by Control-V, Control-R, and I did disable paste. So when you type Control-V, it'll think you're typing a special character, Control-R, and then, okay. Seems like there's a problem though. I typed in 0 hex 1269, and I mean it should take me to main, but if you look at the backtrace itself, this symbol, if it works, I think it should. This is smart. It should know that this should point to a function, but and 1269 is over there. But why is it still not pointing to a function? And we want to throw out any ideas. We just give you for function info address win. Okay, that is very much not the address win. Seems like there's still some extra protections going on. But I guess the intended solution to this was, I overflowed the character 6, 9, and 12, but there's still a bunch of garbage in front. So it's not just a matter of typing in all of the special characters, but it's also managing to fill in the zeros. Now, how do I type 0? How do you type, I mean, if I just type normal 0, that's a special character. How do I type in the special null character null? Well, how to type null in terminal looks like it's just a bunch of ats. Okay? So theoretically, if I type in the payload, let's just run it again. This I Control-V R, and then Control-V at, fill it up with a bunch of zeros. Okay? That gives me an address. Unfortunately, I have turned on, I think, address space randomization. So there's still some protections that are preventing me from running this correctly because of the way I compiled it and not the way they gave me the original. So let's just try running it against the original. So on debug, vol. And if I remember correctly, offset is 40. The pattern they want is, let's see, 0 hex 40, 12, 69. So info address win 4, 40, 12, 56. Okay. Then I Control V Control R, the at character, fill in a bunch of nulls. Control V, oops. R at Control V, and then Control at R at Control V. Give me a second. Oops. V. Give me a second. Control Shift Space. Alt Type 0. Control V. Control V. At V. Control V. At. Okay, no, I need to type. Let's see. Control. We'll just. Oh, I'm not running it. Sorry about that. Start. Step. Step. Oh. Step. Continue. V. And then I want I. Control V, Control R. The actual at character, and then a bunch of null characters. Hopefully this works. Segmentation fault. Backtrace. This. Boom, debug. Break 30, run. If I do through control, once again, try it. I, V, R, at, put in a bunch of 0 bytes. Step. I think I need a longer offset. 50. Let's try the 56. Run. Control. Let's see. So this kind of demonstrates the difficulty of just trying to do it by hand. You might get some inconsistent results based on how you compile it and doing by hand. Fortunately, what Pwn Tools does is it allows you to precisely control exactly what you want. So using just a few lines of code, I can just replicate the whole process without that very painful process of trial and error. I can specifically define offset 40 characters. I have an address I want to jump to, and then finally, I define a payload. 40 characters of offset to just put the address in the right space, make the address and put it into the right format. So it's little endian and also has all the zeros padded out. And if I just send this, I'll demonstrate the exploit way easier. So go 1, Python solver, and /phone. Starting, stopping, local process, send line payload, and p.interactive. Okay. And then, as you can see, thank you for using our service. There's a little you got the flag here. If you remember from last time, what the vuln.c function is, once you hit the win function, it will try and open a file and read it called flag.txt. For me, I just put you got the flag. I got the flag. So now that I've demonstrated this exploit locally, let's run it against the actual challenge instance. Run it against to get the real flag instead of just showing that it might work on my computer. Connect. It will. So instead of local, I want remote. Actually, elf.binary send line payload. P equals remote. And what is it? It just defines connection as in I need a host and a port. So host, I need a port number. P equals remote. And if I just run it from here, there we go. Thank you for using our service, picoctf. We have a flag. Okay, that was a bit of a long-winded process to explain just, oh, I put a bunch of stuff in a buffer and I put enough stuff that I could write stuff into the return address. Does anyone have any questions about what I did, how I did it? Any questions so far?
Go back to how did you manage to put special characters into your input?
Sure. I guess I can just demonstrate it with clear. Exit pon debug 0. I'll just use the debug version so I can just show it in the. Okay. I can just show the register value directly. Break 30. If I run, if I just type like, I don't know, ASDF into the name field, the exact hex, what gets stored in the buffer variable, in the variable itself, is just the hexadecimal representation of the ASCII characters ASDF. And, you know, and if I just type something like, 0 hex 12, 0 hex 13, well, I'll just do the original payload, 0 hex 40, 0 hex, 1, 2, 0 hex 5, 6. What gets put in there is the string characters. What gets put is just the hexadecimal representation of the C characters in ASCII. You know, A is 41, B is 42, and whatnot. So that goes the question: how do I directly type the hexadecimal values? How do I make sure the value in here? See if I can print. Let's see. If I got a hex 30. Let's do like 16. I think this is how you represent X buff. I'd have to try and I'm trying to remember how to print the exact value, the exact data. But what gets stored in there is just the ASCII representations of the characters and not the actual hex value. So what I do is specifically to type the character 0 hex 12. I mean, what is the hex character? Oh, hex character 0x12. The hexadecimal character is an ASCII control character DC2. I just want to get a poll for everyone. Can everyone like look down at the keyboards and find the key DC2? I will give you $100 if you're able to find a key that says DC2.
Coming from the club money.
Is it coming out of club money? I was gonna pull it out of my wallet, but I mean, I see a D, C, a 2, an at, but I don't really exactly see a character named DC2, and that's because it's a non-printing character. When you try, I mean, even when I had it up on CyberChef, you can see, you know, 0 hex 40, 0 hex 69, it corresponds to the characters at and I, but 0 hex 12, it's too low. It's out of range. It's not exactly a character you have to type. So you have to use hacky workarounds to type whatever character, to just like type that character into a terminal without having it on your keyboard. So I was going around trying to find it as like, oh, Linux control space. Windows, I think if you have like a numpad, which I don't have a big laptop, so I don't exactly have it. If you hold down Alt, you can type special characters like null, 0hex12, emojis, whatnot. Or in Linux, you can use a special escape sequence. So Control V. Let me just run it again. If I do Control V and then Control and like some other character, it will actually. So this Control at would be a special sequence that actually represents 00. Of course, and now you can see that the data that gets stored into the buffer is actually literally just 00. All of this pain and suffering could be avoided if you just use something like Pwn tools. Instead of having to worry about, oh, I need to escape a sequence, what character, special character I need to type, I can just specify directly, just 0hex 401256, and no need to just worry about all the ways to type characters that don't exist on your keyboard.
Can you go over how you address again? I don't know if it's just kind of hard to see.
Yeah, when address, this is because of the way the program was compiled, this address is going to be same every time. I know that when I was doing demonstrations, sometimes it would give me addresses that are not 0hex 401256, and that's because I forgot to turn off the security features. So what I essentially did was, let's see, this is not the insecure version. So pwn debug vuln. Just open up in a debugger. You can just say, oh, I know there's a function called win some point. Just give me the address of win. And it's a little hard. It might be a little hard to see, but this function is at some memory address. And you could do it. I mean, if you go into any of the C programs you could do for class, you could probably execute something similar and just look at where are they in the memory. All right. Any more questions before we go? All right. That was just buffer overflows with the source code, but at some point we'll cover reverse engineering, which is no source code. Protection against overflows. General consensus at this point is use Rust. I know Ethan is very happy when I say use Rust. But unfortunately, a lot of development work is still in C and C++. People are still trying to change to Rust. We'll see how it goes. But at the end of the day, buffer overflows happen because you're not doing limit checking. I want to say, I want to write two jillion characters into a buffer. The program should stop you at some point saying, hey, this buffer is only 16 bytes long. You shouldn't be able to write more than you can. Or, of course, as some of the difficulty I had doing the challenges was, there are operating system features to protect you against stuff like buffer overflows, like Stack Canary. You probably saw me when I was compiling it. I said, let's see, F no stack protect. Trying to find the terminal. My bad. Go. Exits. GCC. Okay. I have to find the terminal, which I did it, but you probably saw when I was compiling, I was doing GCC F no stack protector. That specifically disables the feature, this feature right here, stack canary, which is, a lot of exploits mean a lot of what exploits want to do is they want to jump around and execute some custom code. What if I just shove something in between your stuff on the stack that you can mess around with, and the return address, which is something you definitely should not be messing around with while the program is running. So canary, if you overwrite that canary, the program essentially crashes. And I guess I will, let me see, I think I have that security feature on, give me a second to find the right terminal. Check sec, file equals vuln debug. And it has all the protections. So you know what? Let's see what happens if I try to do a overflow with a canary. debug. And if I type in more than, I think this version is 56 characters, it will overwrite the stack. So I think that's definitely enough to overwrite the canary. And it will crash your program, gives you the message, stack smashing detected, terminate. So if any chicanery is going on in your program and your stack canary has been modified, it immediately just terminates execution. You can turn it off, but when you're doing, actual work, don't turn it off. Okay. Second type of binary exploitation vulnerability that unfortunately was not covered last time is something called a format string vulnerability. Can someone just like throw out what this program does?
It tries to print user input twice, except the first one's like it's usually at the format string, which is not input.
Yeah, I mean, yeah, I'll discuss a little about why, but we can agree that in theory these two printf statements are exactly the same, right? Or should do the same, considering if I just put in like user input equals a string JSON or whatever. Everyone agree about that? Okay. Unfortunately, if you just pass a variable directly into printf, what you can do is, what if I had the actual string %s in user input instead of just having like a normal string to read? What if I said %s, %d, and then some other things? Well, it would print. Actually, you know what? Let's give it a try. See if I can throw up a random C program. There you go. Dingus.c. io.h. Int main. Okay. Char buffer equals %s. I'll just throw in those random statements. Printf buffer, and just for good practices, because we're totally following good practice here. GCC dingus C. Yeah. Ignore the warnings because we love immediately segmentation fault core dumps. If I just say like temperature check. I'll finish this and then we can do temperature check. Let's see, %d. You know what? Just for funsies, equals 4. See what happens. Oh, recompile it. My worst enemy. Okay, it's doing a lot of illegal access. But essentially what happens is if you pass it in format strings into printf, printf doesn't really know what to do with it. So it will start grabbing other bits of memory to read. So if I do like %x or %p, hexadecimal, I believe this is read a hexadecimal value, read like some value from a pointer, it will actually just start grabbing memory from your program to read. So if you do a program without careful protections, you can be like, let me read the entire stack. And if you have anything that's you want to hide on stack, that's probably not good. In fact, so the logic goes, if you have a canary that gets overwritten, why not just read the canary and just insert it into your exploit to avoid tripping it? And then with a vulnerability like this, you can read the canary and be like, let me just not change it and not trigger the vulnerability, even though you're doing shenanigans. Also, there is a funny printf flag called %n. What does it do? Printf %n format flag. You know what? Stack Overflow. We're not going to read AI this time. what %n does is it prints the number of characters written so far into an int variable. But what if you don't specify an int variable? It's just going to start writing to memory. And the really funny thing with a format string vulnerability is you can chain these two things together. You can be like, oh, let me read a bunch of random memory, and then let me write to a specific place in memory. So something like format string allows you to arbitrarily write your code in memory. It's a little hard to explain because the actual exploit is very painful to read. But give this a try. Secret menu. Let's launch format string. Let's see. Okay. Oh no, this is oh, just open it here. String. Okay. You have a so here's the program. There's a secret menu 1, secret menu 2, and a flag. Give me your order and I'll read it back to you. You know what? Let's just run it and see what happens. They don't provide an executable, so I'm just going to directly connect to the challenge instance and just run it there instead. Control Alt T doesn't work anymore. Okay. Test. Okay. What if you can see that what they printf, they directly print what's in the buffer without specifying format string. So what if I just started doing this? You know what? I'm just gonna copy paste it a couple of times. %x, 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 %x. It's a bunch of random hexadecimal data. I sure wonder what this means. Give it to our good friend CyberChef, because I cannot read hexadecimal in my head yet. But from hex, not to hex, but from hex. Interesting. What if? And data, it might just be in little endian form. So let me just like endian, swap endianness. Let's like swap it around and just like see what's going on. Oops. No. Okay, not enough yet. What if I just gave it more? V. Okay, that's a lot of data. And we've gone to a bunch of null data, which is vaguely promising. No, www. We haven't seen the pattern of pico CTF yet, so. Oh, my word length has to be at some point. Okay, maybe %x doesn't work. Let's do %p. %p. Oops. Let me just use here. Just read a bunch of data from the program. Interesting. 0 hex, 0 hex, 0 hex. This looks mildly promising. Ooh. Host, length, solve. Oh, what the heck is this? CTF. That definitely looks promising. Might be a little too much. But if I rearrange the data correctly. Pico CTF. This normally the flags are actual strings, so maybe we're not at that point yet. Pico CTF left brace. Let's remove some of the data and see how it helps. Pico or Indianus. See what this does. This data looks kind of irrelevant. 0 hex, increase, tweak around it a bit. It looks so promising. We're so close to it, but I think just a tad off. Maybe if I remove some of the extra data that I know is.
Did you use %08F or %08X?
Say again?
Did you use %08X or
0% 8x. You know what? Let's give it a try.
If you have like something that's like the top bits are 0, then they'll omit those like as hexadecimal.
So %8x? 08x. No periods or
nothing else.
Okay. Skip. Let's give it a try. That is definitely a lot of data. To swap Indian, do I want Pico? No. Well, number 4 seemed to be working a bit earlier. Okay, I don't want to take up too much time because that's the trap we ran into last time, but you can probably tell that there is some kind of hidden data in there. You're able to read it. The flag.txt, you're probably able to read whatever was pulled from flag and stored in that buffer. So format strings, you can read data, and I'll demonstrate in a bit a challenge you can use to actually arbitrarily write some data. Okay. Any questions on that? I know it was like a little hand wavy, but hope you kind of get the idea of the dangers of just writing printf in a variable. Okay.
So the better practice is to just give it a string.
Yeah, you have explicitly give it the format it should read. Don't let users specify what kind of format they want to read. You should always give it yourself.
Okay.
Yeah. Okay. Okay. Given that we know that we can probably arbitrarily read and write memory, it runs into these very funny attacks. There is a type of attack known as shellcode where you literally generate assembly instructions to run /bin/shell. If a program, for example, just said, give me a bunch of assembly code and I will run it, no checks whatsoever. You could generate something called shellcode. You could generate, let's see, Linux shellcode. And I'm not going to just generate it. Let's see, shellcode generator online. Yeah, cat read.txt essentially generates the assembly instructions needed. And we know that assembly instructions you can also encode them in the binary format. So if you just push the right amount of the right binary characters into a buffer and the program happened to read it, you could get the program to essentially launch a shell for you. People have gotten smart about it though. They're saying, hey, you're using weird portions of memory that were never intended to as program instructions when understandably, the only parts of code that should be run in memory is the actual code section and not, I shouldn't be like pulling code instructions from the memory section. So the trick they did was DEP, data execution prevention, I'm trying to remember. But essentially what it does, it tells when you compile a program and run it, your code gets split into segments, and then the operating system will say, you can read the segments, this segment you can run code from, and this segment you can't do. Essentially, they want to separate the ability from areas you can read and run code from to areas that the program can essentially write from. So, like say stack memory or heap memory, maybe you shouldn't be pulling random code segments and executing it from user-controlled memory, whatnot. And then there's another step. You actually saw it a bit earlier when I was trying to demonstrate the echo shell exploit. You'll see that when I was running it, sometimes would get addresses that start with 0x555555 instead of the expected 0x401256. If you've taken operating systems, you might know the idea of virtual memory. Your program thinks that it has a lot of memory when it could actually be in, or your program operates on a certain address space, even though in the actual computer, because you're doing time switching and switching between programs, it might not actually have be running from that part in memory. So essentially, 0x5555, whatever address, it could translate to any place in your computer. It's just that the operating system tricks the program into thinking it can run stuff from this memory and then does a translation in the back. Pi and ASLR, essentially what they do is, we know that if you have an exploit running on a program that targets, if you run the program and make it jump to address, I don't know, 000676767, it will blow up your computer. What Pi and ASLR does is every time you load the program, let me just randomize where it loads in the memory. Maybe you'll get you'll get like address space 0.0 to 100, maybe 100 to 200, whatever. You can't really predict what it does. So when the scheming hacker says target address 67, they will, when they try and run on someone else's computer, because the address space is randomized, it might not actually mean anything. It might be out of bounds. It might point to not that vulnerable space in memory. It could be anything. So all of the protections, so let's see. So this protection, let's see, checksec file equals a.out. No canary, but it gets relocated. There's a little bit of randomization going behind, so exploits are a little harder to develop. Also, they're also doing a funny trick. What if we put the code in, the typical layout, it's like code, heap, stack, whatnot. What if we actually shuffle them around in memory? What if I put my program code next to, like, I don't know, Chrome's running code, because, that's just happened to be spaced there. Makes doing a lot of the exploiting less unpredictable, which leads to this development of thing called return-oriented programming. I'm still not that familiar with it. You can look it up and see what it does, but essentially what it does is use your program, chain together like random assembly instructions that already exist in your program instead of injecting new code to create an exploit. It is absolutely devious, and for better or for worse, that's how most modern exploits in this day of age of operating system protections work. I recommend you do a bit of reading to figure out how it works, because it is pretty devious, and I would still consider it out of the scope of quote beginner level class. Okay, any questions about all of the ideas I've been throwing at you so far? Can we get a temperature check? It's okay to be in the middle if I've been like rambling on about random topics. Kind of about 50-50. Any questions? Any points of confusion that I'd like to clear up? Guys, I can help you if you don't ask questions. Are you so confused you don't know what questions to ask? That's fine. That's
I need to try to actually know what questions I have.
Okay. Then I'd recommend, I do have the challenges I've been using for this class in the on the website, and if you want to look at how the actual exploits work, there are plenty of people who've done write-ups and have challenge solutions online, so you can see like the source code, what they're doing, and whatnot to on that challenge. Okay. Okay. let's cover reverse engineering again because I don't think we got a very good coverage in the 10 minutes I did. Some of the tools, Ghidra and Dogbolt. So Dogbolt is a website version, which I recommend you all use instead because it generates very convenient. So it has all the paid tools and it will generate the reverse C code for very trivial challenges, which I mean is pretty much what we will be giving you. We're not going to ask you to decompile Google Chrome and tell me exactly how it works. No, it's going to be some simple C code. So time check. Yeah, 2:30. Okay. I will do, so let me just do a quick challenge to just show what reverse engineering challenge looks like. Okay. This is from a CTF I did earlier in the year. So challenges, this is actually the source code of challenges and how it works. So let's see. CTF 985 Miami. Okay. It goes up a directory. So I was in like 4 folders deep, and I went up like 4 folders into a different folder.
Okay, I was like, where is it?
Yeah. Okay. Nothing done code. Does it have the executable? Clone make generate. Normally this generates a Docker container that you can host, but I just want the executable. Bruh. Runs all make commands. Clone make. Build. Publish. Why not? Clone make. Publish. See, publish. Miami. Bruh. Actually, I don't know why I decided to build it myself. I still have the actual challenge files on my computer. You know what? I'm going to, this is, spoiler alert, this is a bit of a buffer overflow challenge, but I want you to take the time to try and study the executable in Dogbolt. So, I'm going to put this in Discord. I'm going to put suspicious binaries into Discord and ask you to run them on your own Linux computer. So, let me get that up. CS. Okay. Nothing has ever gone wrong with posting suspicious files in general. Miami. Okay. Let's take about 5 minutes. Download the file, put it into Dogbolt. So dogbolt.org. Put it in, and you don't have to figure out how to exploit it immediately, but I recommend you come up with a plan and figure out. Yeah, just come up with a plan. Maybe discuss with your neighbor to try and figure out what we can do. All right. 5 minutes. Let's do it. Sorry, I'm gonna step out and get some water real quick. It will be a bit obfuscated, but I think the general idea should be visible. So let me give it a try myself. This is my development folder. This is Sunshine CTF and Miami Dexter. And I believe they did keep the function names in, so it should, yeah. Just gonna cut it down into. See if I remember how to open Ghidra. Ghidra is also a very nice tool, but I much prefer the web console of Dogbolt because Ghidra, despite being free and by the NSA, it requires you to download Java, which is, I don't know, Minecraft. Ghidra. Like, I have to, in order to run it, I have to run some, like, Ghidra run up. Takes, like, forever. This is me just pulling up tools just to show them off, but yes. Web browser. And then open. File. CTF. Has everyone been able to get the decompiled code into Dogbolt? All right. Sure. What is it? This is great. If only. Bruh. Oops. Okay. File. Miami. This auto analyze. Analyze. Think. It's been a while since I've used Ghidra, so I think it should be functionally similar to this. Okay. All right. Okay, it's been about 5 minutes. Does anyone have any? I guess just like tell me things you saw about the program. Anyone?
There's gets that basically doesn't check buttons.
Oh, yep. There's a function called gets. It's like buffer overflow. Okay. Does anyone know? Anyone want to throw any ideas of how you think you would get the flag? Is there a function that says get flag here or? One. Ownable buffer. It is a bit confusing to read, but there is indeed a file called read flag. It will read it and open the flag. So, does anyone know what function calls read flag? How read flag is called?
In Rome, there's an if check for whether a variable is equal to some value, and then if that if check passed, then it runs the read flag.
Okay. All right. Check a variable. Is there any way to set the variable? Any way to poke at it? Buffer overflow? Yeah, it doesn't seem like this variable is like there's no scanf into that variable, so it seems like we're gonna have to buffer overflow it, and it seems that gets, and then you overwrite that buffer, and you write the value leak code as opposed to dead beef into it. It will read the flag. Okay. Sounds pretty straightforward. In this case, I'll just quickly show my solution that I did a while ago. Let's see, code, VS Code. I'm just gonna open it manually. Give me a second. Sunshine CTF, and once again, it's our good friend Pwn Tools. I open it. I open the binary. I figure out the offset in this case through experimenting with that number, that cyclic pattern, and watching the debugger. If you put in 76 characters, it will, after the 76 character, it will start writing into the variable that's holding the deadbeat character. So buffer size, target value, payload. I build the payload, and remember that the variable is an int 32t. I mean, it could be anything. It could be any data type that's 32 bytes wide, but we know that since it's 32 bytes wide, we have to align it and pad it out. If it was, if it was like a 64 byte variable, I just change this P32 to P64. But do it, send the payload, and then see if we can get the flag. So let me spin up the Docker container that hosts the challenge. Let's see. I5 Miami pwn make docker start. I'm starting container Miami. Okay, it's on port 25601. And if I run this, CDF, Sunshine, Python, Miami. So I execute an overflow 76 characters long and then insert the target value. There we go. All right. I can't put in the flag because the competition has been over for the better part of a year, but that's pretty much that is how it goes. So that was buffer overflow. Any questions? Any questions about how this one operated? The tooling concepts seem fairly understandable. Okay. Okay. Let's show off the format string vulnerability. Format string vulnerability instead. This is the payload. This is exactly why I advocate for using Pwn Tools. Pwn Tools, I can just be like, I need to send a payload, and format string, I have a secret key address, and I need to overwrite that secret key. There's a nice library function in Pwn Tools that will generate the format string because, I don't know, I mean, this is essentially what the binary payload would look like for a format string. So it's like, print, I'm trying to remember, it's like 222 blank characters, and then pad it, then insert these characters in, and then it's kind of horrifying. I would not want to write this by hand, so I generated it using a library, and then it just handles the rest for me. But if you'd like to, I guess if you want me to sit down and explain to you every single byte of what this does, I will, I guess, come to office hours, because this is very painful. Okay. Okay. On a scale of 1 to 10, I guess it's like temperature check. How confident do you feel with buffer overflows and reverse engineering? I guess, has everyone taken a look at assignment number 2? Okay. I will say that it is the latter two assignments will not be as hard as some of the horrifying payloads I've shown you. I think it's fairly straightforward. But if you have questions, come to office hours.
The last two parts.
Yeah, the last two parts of the not the symmetric encryption, Ethan's cryptographic funhouse. It's the B and C. Okay. We have about 15 minutes left. Ethan, would you like to go over the solutions for homework one?
You can move that to Thursday. You can go over the crypto examples.
I'm gonna defer that to Thursday.
You want to defer that to Thursday?
Yeah.
I'm happy to talk about homework.
Last call for questions on reverse engineering and buffer overflows.
We'll have office hours as well.
Okay. How do you want this to be reported?
We'll just strip here.
Okay. Can I have a terminal session? Yeah. Okay. Oh. This is Linux? Okay. All right. So I will quickly go over first assignment and the solutions. Broadly speaking, I graded all your homework. I didn't dock a lot of points, so the major points that I docked were if you didn't actually complete the sections, which again must have evidence, you must have your executive summary, and you must have an analysis section. So if you missed those, you would have been bumped 10% per section that you missed. And that will continue onwards for the rest of the quarter. So please make sure you fill those in. But otherwise, I believe I was pretty generous and lenient with the grading. About the evidence, please remember to take screenshots and write down the commands that you use in your report. In the future, you're not only going to miss 10%, but your score will be capped at 60% if you don't do that. All right, so I'll quickly go over the solutions. There were some interesting solutions that I saw. I'll try to talk about them as well. So the first one, generate the log file in that directory if and only if it does not already exist. So the solution was literally you just use the touch command /var log / I think it was ECS198F logs. So that was the command that you should have ran. If you run this, you might have some problems with some people add the sudo. Any of these combinations would have gotten you 5 points. Some people decide to do some additional checking because touch does modify the timestamp of the logs file. So some of you did something like this. Check to see if this file existed first. So you did this ls-d, make sure it's not a directory or some combination of that. Then you used the redirection to pipe any of the output into /dev/null. Then you did this or symbol, and then you did the touch command with the /var/log /ECS198F logs.
So sometimes the first command failed.
So yeah, so if the first command failed, then it would do the second one. Otherwise, it would use short circuit if the first command was true. So you were able to list that file out. Then the output would be piped to /dev/null, and the second portion wouldn't execute. So if you did that, you got 5 bonus points. Some of you use some other commands like the find command. Some of you use the test command. The test command was not an allowed command, so you only got 2 extra points if you did that.
What if CP, like using CP instead of the...
Using copy, where are you copying what?
If you use CP from the null, you could still do that, like from a null directory to...
You want to copy from the null directory to where?
To the directory you ran, basically the 198, whatever file directory. If it doesn't exist, it will make it. If it exists, then it's not.
Well, the thing is, if it does exist, then you're just copying null bytes into the file, which is not what we want.
Not null, it will make the file, the wrong file.
But what if it already exists, right? Copying will...
It'll fail.
Oh, it wasn't the second portion. Use CP.
No, it's just, I use it for mine. You do like CP, then you'll give it the like null, the one we just gave right now, which is or something null. And then the other one, and then you'll submit it like and then you'll give it the path for where the file should be, and that would work if the file exists, the copy will fail. If the file doesn't exist, the copy will just make it.
What did I grade your solution as? Did I grade as?
I did both. I did it both ways. I did the touch,
Oh, okay.
touch does not date it because I didn't use the or thing.
Uh-huh.
I didn't want to use that. When I was reading for a copy, there is for the man file, you can like use one of the flags there, and then it'll allow you to not copy if the file exists already. Okay?
Ah, interesting.
You can look at mine if you want.
I'll relook at yours then. But this was additional. You weren't required to do that. Part B, append the output continuously. That required you to use the watch command. Watch the output ECS198F log, and then you want to append, which is that double arrow sign, into that /var/log/ECS198F logs. So that was the solution to part 2. For part B, part C, search the file for any lines containing that. So you can just do a grep. You want to grep for essentially what was Ethan or Keel. The file you want to look for is log CS198F logs. You want to pipe that into -v, not JSON, and then return the number of unique lines. So the interesting thing about unique is that you actually have to sort it first. So you could do something like sort unique C-L. That is one of the solutions. You could also do sort-U, which would give you the which would already sort it and filter out all the uniques. Do something like this. Unique-C would give you the unique counts. So some combination of those was expected. For part D, a lot of you decide to, so if you look at the ps-aux command, a lot of you decide to write a huge regex for me, so using sed or something like grep, and filter out everything in totality. That was an allowed solution, but you could have just as easily did something simpler. So -E. So because we know those two columns are the ones that we're looking for, and those are the only ones that have numbers with a dot in between, the rest of them don't really have that format, so we can just directly do 0, 1 with an explicit dot, 0 to 9, any number of spaces, or we could literally expressly put 2 spaces over there. Then you have, I believe it was just a 0, a dot, 0 to 9. And this is the solution that a lot of people gave, and then the head -N20. Yes, this doesn't actually is not fully correct because you actually do need a space at the very beginning of the regex.
It can also match inside the process name.
Yes, it could match inside the process name, but that generally doesn't happen, and I accepted the solution. You could have added more things to really like force it to be the case. So you could add like the beginning caret with the names and the PID numbers, and I believe that should force it to match those 4 columns. Some people interpreted it a different way, which was they decided to interpret as truncate the 2 columns and only output those 2 columns. I accepted that way of interpreting this assignment as well. One person found that the -M20 in the grep command will just exactly take out the first 20 lines, so you didn't have to even pipe it into the head command. And so I accepted all of these solutions. But yes, that is correct. You could have matched some of the ones in the process name, and I decided not to deduct points for that. The other way, the second way of using part E, using the awk command, so you do awk. There are a lot of solutions, so a lot of people did like begin a count, so you can actually count the number to 20, but the easiest way is actually you use $3 is less than 2, and $4 is less than 1, and you want the number of lines read to be greater than 1 to remove the header line. I believe I docked points off if you didn't remove the header line, or at least if the outputs weren't consistent. So that was what I was looking for. If part C and part E, you had outputs to the solution that were not the same,
I dock points off that. But if you interpret them both ways, so if your part D had a header line and your part E also had a header line, I did not dock points for that. And I believe you can do something like count plus plus is less than 20. I believe this would also work. There you go. So single line code. So the reason why this works is because if you look at the awkman pages, if you have an empty action, it will print out that entire line. By default, variables are initialized to 0. So by doing this, the count was initialized to 0 at the very beginning. Some people explicitly put a begin and they put an exit clause. Those are all acceptable. But this is the most direct way of doing this question, I believe. Part E, sorry, that was part E. Part F implements the command using p kill Firefox. Easiest thing to do is like you can use awk directly to search for the pattern Firefox, and I believe it was $11 that it matched Firefox, and $11 doesn't match awk. Then you want to print $2, which is the PID. Then you would pipe this into xargs kill. So some variation of that. Some people use grep. They did the grep for Firefox, grep-v awk. Sorry, grep-v grep, and then you piped into awk print $2, and then you piped into xargs kill. Some combination of that, or you could even try to run kill inside with some system command. All of that was allowed. So that is the solution to homework 1. Any questions? So a lot of variations. I believe the average was very high, like 99% or something. Yeah. For homework 2, if you're writing code, please include your code files either directly in the report itself. I gave instructions on how to do that on the website, or you can upload files directly. So over here, you can use this file formatting and embed base64 into your PDF file of your submission, or you can just directly upload your code into Canvas as well, in addition to your report. Any standard coding language is acceptable. Don't use some esoteric programming languages that no one uses or is like impossible to read. But otherwise, anything is allowed for the most part. Any questions? Yes.
I have a question about the calling machines. I don't know if it's just me, but I can't like upload any files
To the
read-only access.
which machines?
The calling machines that we
How were you trying to transfer files?
using SCP.
SCP didn't work.
It should work. Come talk to me after class.
Yeah, when I run the touch command, I get like a message saying I only have read-only.
Oh, that might be because of which. Well, we can talk about it after.
We'll help you troubleshoot that. Yeah.
We'll troubleshoot that and try and get that working as soon as possible.
But you should be able to copy and can you do sudo on your machine?
No, it doesn't do it.
On your own laptop.
No, on Kali.
No, I can't.
You can't even do sudo.
I don't think
You should have sudo privileges too.
Well, let's talk about it after. I can sit down with you and like see what's going on.
Okay.
It might be because of things not under.
All right. That's it. I will stop.